Okay, today's lesson is 11-4b of the central limit theorem, and we are going to concentrate on using the normal distribution to approximate the probabilities of binomial distributions. Okay, so one of the things, you're not going to run into it, but you might need to know it, and you might come across it in another course. When the probability of success is close to zero or 1, and the number of trials is relatively small, the normal approximation is not accurate. So whenever we do this, we do need to always make sure that n times p is greater than 5 or n times q is greater than 5. Remember, p is our probability of success and q is our probability of failure. Okay, so just something to keep in mind. I don't think we even have any examples that don't have that or that have that as a problem. So it shouldn't be a problem. Okay, now, more importantly, if you remember the difference between discrete and continuous variables, binomial distributions are discrete, which is what we see on this diagram right here. Okay, and normal distributions, on the other hand, are continuous, though they look like this. Okay, so you can see there's a bit of a gap. It's not smooth and continuous like we have over here. And so because of that, we use something called the continuity correction factor when we are finding the probability of binomial distributions. Okay, now there is a chart. I'm going to skip all the way down to the bottom because that was the best place for me to put it. Okay, there's a chart here that you can remember and have handy with you, but I'm going to give you a little visual that I think makes it easier to remember this chart. Okay, so first off, if you are looking for the probability of x equal to a certain number, whatever that number is, okay, if you will think of it on a number line, okay, here is my value c, whatever that point is in the middle, and you've got to think about going 0.5 to the left, 0.5 to the right. So that's c minus 0.5 and c plus 0.5. Okay, if I want the value of x equal to c, then I'm going to set up and y'all, this is what we're going to be doing when we're using that button. I got to put the right thing here. When we're using this button in ClassCalc. Okay, so this is what changes with these problems. When we use that button, and if I want equal to, then this is going to be my range, and you're going to see it as I go through. Okay, now if x is greater than c, okay, again, if you think of c being at the middle of this box, if it's greater than, then I'm going to use the number that's c plus 5. If it is greater than or equal to, I'm going to go to the left of my box and use c minus 0.5. If it is less than, then I'm going to go to the left side of my box. And if it's less than or equal to, then I'm using the right side of the box. So you're going to see me draw this diagram when I do these problems. So let's go start. Now, the other thing, so when we are going to approximate a binomial distribution with the normal distribution, these are some steps that you can follow. So when I do this problem, and I'm going to read it in a second, but when I do the problem, you're going to see that I number these steps as I go through the problem, so you can look back up. It doesn't all fit on the screen right now, but you can look back up and see exactly what I did. And then I'm going to show you side by side where you can go straight to ClassCalc, and I think it simplifies the process. And I've had a lot more success, again, with people using ClassCalc because they don't get bogged down with all the computation involved in these problems, and they get them right, and it takes a lot less time. So let's go start. Now, it says, according to the results of an advertising survey sent to customers selected at random, 65% of the customers had not seen a recent television advertisement. Find the probability that from a sample of 50 customer responses, 15 or more did not see the advertisement. Okay, so from our step one says find the mean and standard deviation. You're going to have to do that no matter what. So in this particular problem, n is my sample size. My sample size is 50. P is the probability of success, which is clearly 0.65. And Q is the probability of failure, which is 1 minus 0.65 or 0.35. So that's the data from my problem. Step 1 says find the mean. And if you remember from previous lessons, mean is n times p. And so that's 32.5. And the standard deviation is the square root of npq. So I multiply that and I get 3.373. Now, the other steps that follow, okay, that's what this is. If you want to go read all the other steps to the problem, that's what you have to do. But I'm showing you how you can go straight into ClassCalc from here and get the problem. All right, so in ClassCalc. So in these problems, y'all, everything written in blue, I'm using ClassCalc. So to start off with, I still need the mean and the standard deviation. So I just carried that over from what we had done in the first step. 32.5, 3.373. I'm looking for a probability. So in ClassCalc, I didn't write this down, but of course, hopefully you remember, we're using, well, you'll see, I'm going to do it on the video in just 1 second. But when I'm looking for a probability, I have to use the button CDF. And so this is what's different, is how do I figure out what to put in these blanks? That's the key difference between doing these binomial distributions and what we did before. Okay, so since it is a binomial distribution, and meaning binomial, it's a problem where there's only two possibilities. You either have success or failure. That's what makes it a binomial distribution. So in this particular problem, they asked us for 15 or more, find the probability that 15 or more did not see the advertisement. Well, 15 or more means x is greater than or equal to 15. So when I think about my box that I drew, that I was showing you earlier, 15 is in the middle, and if I'm greater than or equal to, then I'm going to go to the left side of my box, which means that in my CDF, I'm going to put 14.5 over here, and of course that starts with or ends with infinity. So I'm going to go put that in to refresh your memory. So from graphing, I'm on the graphing tab. I'm going to click on Stat, Distribution Plot, Normal Distribution, and our mean that we got was 32.5. Our standard deviation was 3.373. I hit enter. And remember, I tell you to hit the magnifying glass if you want to see it. So here we got it. And then I'm looking for a probability. So I'm going to click on CDF. There's my interval. And we just calculated that now I'm supposed to put 14.5 there instead of 15. And you can see that that is a 0 point, a lot of nines. Okay, we don't want to say 1 because it's not the whole thing. So you will see also that it's exactly what we had up here, 0.99968. That was done on a calculator, or if you looked on the Z chart, okay? But 0.999, which becomes 99.9%. So that is a problem that is less than or, greater than or equal to, or if it was less than or equal to. We have one here that is a little bit different because it's going to be in between two numbers. So let's look at this. Suppose a defect in a second model by the same automaker is expected to affect 20% of the cars that were produced. What is the probability that there are at least 8 and at most 10 defects in a random sample of 30 cars? So from my problem that it's a different problem than I didn't give you, so that's why I have to give you the information. They told us that the sample size was 30. And the probability, well, we still have probability of success, and we know the probability of failure is 0.8 because 1 minus 0.2 is 0.8. So the first thing we always have to do is go find our mean and our standard deviation. Okay, those are your formulas of how you do that. Okay, I'm going to actually go ahead and go to the ClassCalc part of it so you can see this is what you would have on your paper to do it. So with ClassCalc, again, my mean is 6. My standard deviation is 2.19. Okay. I have to find the probability, so I'm going to click on CDF. Okay. Now, it says there are at least 8 and at most 10. That means that X is between 8 and 10. So if you think about that on a number line, that's 8. I want X. It says X is greater than or equal to 8. So greater than or equal to, I go to the left side, and I'm going to have 7.5. and x is less than or equal to 10, which means I'm on the right side of my box. And so that's 10.5. So these are the numbers that I'm going to go put into ClassCalc. So let's go do that. I'm going to clear my CDF, and I'm going to come up here and I'm just going to type over it. What was my mean was 6. My standard deviation was 2.19. And I hit enter. And if you hit the magnifying, it'll recenter it. Okay, so I can put it there. And my CDF, we figured, was 7.5 to 10.5. And you can see that the answer is 0.226744. Lots of decimals. But I generally don't write down all those, but enough to see if, and that's the corresponding percent. But I want to tell you that, y'all, ClassCalc is going to mark it wrong if the directions say round to the nearest thousandth. So you would put in 0.227. Okay. If it tells you that you can do the thousandth or the percent, I would encourage y'all to keep it as the thousandth and not change it, because several of y'all don't know how to change it to a percent. And that way you'll just know that you get it right. Okay. I have the rest of the steps here if you wish to do it the long way and find out all your calculations and get your z-values and use the z-chart. There is all of the same information, but you can see a little bit difference here, but that's so far away, we will still get the same answers and you'll enter the same answers on your lesson check. So I hope you thought that was pretty straightforward and easy. If you have any questions, please email me or set up a Google Meet. Thank you so much, and y'all have a great day.